The future of hypersonic flight is exciting. While some experimental craft are currently shooting for Mach 1.5 to 2, and Boom Supersonic is now assembling the XB-1 supersonic aircraft that could reach Mach 2.2, we need to be ready for the next wave of aircraft that can, for example, go Mach 10, or 10 times the speed of sound. That's 7,672 miles per hour. Traveling so fast will present some challenges, so researchers need to study how certain objects and materials will respond to those speeds. So, the engineers at the Southwest Research Institute in San Antonio, Texas, used a giant gun! According to the researchers, when something reaches over Mach 5, the air will chemically decompose around the craft. Some points behind the shockwave actually get hotter than the surface of the sun. The objects typically heat up, melt, and chemically react with the air. And that sounds amazing. It's not like you can recreate all of these conditions in a wind tunnel. So the researchers used a two-stage light gas gun system to simulate hypersonic flight conditions, aka a big gun. The gun can generate velocities up to 15,660 miles per hour. The system itself is 72 feet long, and it normally is used to study ballistics. Right now, the engineers are shooting objects at up to Mach 15 to see how they heat up, melt, and chemically react with the air. The work could one day help create the hypersonic aircraft of the future by addressing the material problems now. Oh, and at 15,660 miles per hour, that's around the world in just over 1.5 hours. Flies are annoying. Thus the phrase, "shoo fly, don't bother me." Perhaps you've heard of it. However, it's fly movement that interests the researchers at the Swiss Federal Institute of Technology. Right now, they're studying the way flies walk, and it could lead to advancements in robot transportation. It could also lead to more realistic robot flies. And who doesn't want that? Flies are capable of climbing nearly any terrain. They have adhesive pads and claws that help them stick to walls and ceilings. It's not just being able to navigate the terrain either, because if robots could rest on any surface, they could become more energy efficient. First, they need to learn about how flies behave. So they developed Deep Fly 3D, a motion capture system for the common fruit fly. The system recorded a fly walking on top of a tiny floating ball with 7 different cameras. To keep it in place, they glued the flies back to a stage. But I mean, let's all keep our cool here. It's a fly. Deep Fly 3D learns how the fly walks so it can teach robots how to move. And it doesn't just watch. The system predicts what the fly is going to do. If it's right, it confirms its hypothesis, or learns from its mistake and evolves. The study was published in eLife Sciences, and the researchers made all of their data available on GitHub. So, just in the last couple of weeks, the Swiss Federal Institute of Technology has published work on artificial skin, amputees merging with prosthetic limbs, and robotic flies. Oh, and we're not just talking flies either. Deep Fly 3D can be used on any other animals, even humans. Yesterday, the University of Maine Advanced Structures and Composites Center unveiled the world's largest Polymer 3D printer. The printer is capable of printing parts up to 100 feet long, and at the ceremony, they unveiled some incredible achievements. First, they showed off a 3D printed tactical center that was printed in 3 weeks. They showed off a 3D printed boat mold that was made from PLA, derived from corn, and nanocellulose, derived from wood, and they used it to build the roof of a boat. What's interesting is that the material is 100% recyclable. Finally, they pulled the cover off of a 25-foot long, 5,000-pound boat that was entirely 3D printed. Now, while it is the largest 3D printer, it doesn't lumber along, and it can build parts pretty quick. The boat was printed in a little more than a weekend. They started printing the boat on a Thursday night at 6 p.m., and by about the same time Sunday night, they had a boat. Many names were considered, including 3D Maniac, which is still my favorite, if I'm being honest. But the multidisciplinary team of researchers and engineers settled on 3Dirigo. Dirigo, which means I lead in Latin, is actually the motto for the state of Maine. Overall, the project cost about $40,000. The boat was outfitted with a 150 horsepower Mercury motor, christened with a bottle of champagne, and better yet, it floated. Guinness World Records was on hand to officially recognize the 5,000-pound 3Dirigo as the largest 3D printed boat in the world. The record was previously held by a 40-pound rowboat. So just really knocked it out of the park there, guys. When discussing how such an achievement was possible, one university official simply said, "None of us is smarter than all of us." I'm David Manti. This is Engineering by Design.